Okay, class, we're about to start section 3.5, Order, Exponents, and the Order of Operations. Section A, Comparing Fractions. We use inequality symbols, this is less than or greater than, to write the order of numbers. We'll be using these inequality symbols to compare fractions. Now, we have this definition box here, which says this is less than means is less than, and this symbol means is greater than. Comparing fractions. To determine which of two fractions is greater. Step 1. Write the fractions as like fractions. Step 2. The fraction with the greater numerator is the greatest fraction. Okay. Now we scroll down here. Says if we think of less than and greater than as arrowheads, a true statement is always formed when the arrow points to the smaller number. So we look at this point here. So we're saying 1/3 is less than the 2/3 here. But it reads as 2/3 is greater than this 1/3. And we look here where this is pointing at. This 5/6 is less than this 7/6. So we'll say 5/6 is less than 7/6. Points to the smaller number, points to the smaller number. Okay, now we scroll down here. It says insert less than or greater than to form a true statement. So first thing we need to do is find our common denominators. We have 9, we have 11. 9 breaks down to prime factorization of 3 times 3, and we bring down our 11. So now we would take 3 times 3 times 11. 3 times 3 is 9 times 11 gives us 99. So our common denominators here are 99. Now again, we go back to what we did before. We take the new denominator divided by the original denominator. So we add 99 divided by 9, which gives us 11. So we take this 11 and we multiply it by this 8. 11 times 8 is 88. Next, we take the new denominator again, divided by the old or original denominator. 99 divided by 11 is 9. So we would take this 9 and we will multiply it by this 10 here. 9 times 10 is 90. Now as we see, 90 over 99 is greater than 88 over 99. So that means that this 10 over 11 is actually the greater value. So 8/9 is less than 10 over 11. Okay, now we come to number 2. Now we go off to the side and find the common denominator of 5 and 9. We bring down our 5 because 5 is already prime, and our 9 becomes 3 times 3. So now we take all the common factors, which they have none, so we bring down all of the factors. 3 times 3 times 5, which would give us 45. So 45 is our new denominator. So now we do like we did in the other problems. We would take the new denominator divided by the old denominator. So it would be 45 divided by 5, which is 9. So we would take this 9 and multiply it by this 3. 9 times 3 is 27. So we take the new denominator divided by the original, which here be 9. 45 divided by 9 is 5. So we'll take this 5 and multiply by this 2. 5 times 2 is 10. So now 27 over 45 is greater than 10 over 45. So we will point the inequality towards the 10 over 45. Or we could do it here. So that is our final answer. Okay, now we scroll down here to problems 3 and 4. Again, we find a common denominator. We have 5 and 3. Both of them are prime. So we'll multiply them, and our common denominator is 15. Now we take the new divided by the original. 15 divided by 5 is 3. So we would take this 3 and multiply by this 1 here. 3 times 1 is 3. Now we take the new denominator divided by the original. 15 divided by 3 is 5. So we would take this 5 and multiply by this 2. 5 times 2 is 10. So that means that our second fraction is larger than our first fraction. So the inequality will point to our first fraction. Now we come to problem number 4. We find a prime factorization of 12 and 8. 12 becomes 2 times 6, and 6 becomes 2 times 3. So the prime factorization of 12 is 2, 2, and 3. Now we look at 8. We add 2 and 4, and 4 becomes 2 and 2. So our prime factorization is these 3 2's. Now if we notice here, I went over a little too far. We actually have 2 sets of 2's that are in common. So we'll write them down as one set. This set we write once, this set we write once. And then we have an extra 2, and we also have a 3. So 2 times 2 is 4, times 2 is 8, times 3 is 24. This is supposed to be 24. So this is 24. So our new common denominator would be 24. Now, for some reason, I keep getting this line with the 4. But we know this is supposed to be 24. Okay, so now what we have here is we have the new denominator divided by the original denominator. 24 divided by 12 is 2. So we would take this 2 and multiply it by this 11. 2 times 11 is 22. So we take the new denominator, which is 24, divided by the old denominator, which is 8. 24 divided by 8 is 3. So we'll take this 3 and multiply by the 7. 3 times 7 is 21. So we notice here that this first fraction is larger than the second fraction. So our inequality points to the second fraction. And we're done with that problem. Okay, now we go to section B, evaluating fractions raised to powers. Now in section 1.9 we discovered that exponents indicate repeated multiplication. Exponent means the same when the base is a fraction. For example, in parentheses, 1/3 to the 4th power is the same as multiplying 1/3 by itself 4 times. Now there is one correction to this that I have to point out. Since this 1/3 is in the parentheses, it's supposed to be parentheses 1/3 times itself. Now on your paper, in your course pack, you could just put parentheses around these 1/3. Then you'll multiply straight across. 1 times 1 is 1, times 1 is 1, times 1 is 1. So your numerator would be 1. Now your denominator, 3 times 3 is 9, times 3 is 27, times 3 is 81. So your final answer here is 1/81. Now we scroll down. We go to example set B. It says evaluate each expression. So we have parenthesis 1/5 squared. So we would take 1/5 in parentheses times 1/5 in parentheses. 1 times 1 is 1, and 5 times 5 is 25. So that is your final answer. Now we go to problem number 2 here. Now if you notice, we had 2 parentheses that are taken to an exponent. So the first thing we do is we would take this 1/4 in parentheses times itself, and then we'll take this 2/3 in parentheses times itself. Now once we convert these exponents so that they would be multiplication, we can just multiply straight across. 1 times 1 is 1, times 2 is 2, times 2 is 4. 4 times 4 is 16, times 3 is 48, times 3, well let's do that, 48 times 3. So this will give us 4 And 48 times 3, 3 times 8 is 24. We would carry our 2. 3 times 4 is 12, plus 2 is 14. So it'll be 144. So it's 4 over 144. We need to simplify this. But let's go back here. We could have avoided this step by doing this here, something that I showed you all before. We could write all of the prime factorization of this numerator together. We don't need to write these 1s, so we will write the 2 and a 2. Now for our denominator, this 4 breaks up to 2 times 2. And then this next 4 breaks up to 2 times 2. And then these 3's will multiply as 3 times 3. So here we have 4 2's and 2 3's. Now we can simplify that out. These 2's will simplify out. These 2's will simplify out. And remember, when our numerator totally factors out, we're left with 1. Our denominator is 2 times 2, which is 4, times 3 is 12, times 3 is 36. So our final answer here is 1 over 36. Now we scroll down here to section C. It says review on order of operations. Now it says to get ready to do the order of operations on fractions, we should review operations on fractions. When you multiply, just multiply straight across. Numerator times numerator, denominator times denominator. Dividing, we always keep the first fraction the same. Division becomes multiplication, and we take the reciprocal of the second fraction. And then we do what we just did with multiplication. Numerator times the numerator, denominator times the denominator. Now add or subtract. You know we must have the same denominator, or the LCD, least common denominator, or a common denominator. We find that first, and we multiply the numerator and denominator by what would make this fraction have that denominator. The common denominator here was 8. Since this second fraction already has 8, we just carried it over here, this 1/8, since it already had 8 as the denominator. Now with this 4 here, our new denominator was 8, so we know we would take 8 divided by 4, which is 2. And remember, like I showed you in the last lesson, we're really multiplying the numerator and denominator by that 2. So 3 times 2 is 6, 4 times 2 is 8. So we add 6/8 plus 1/8, which gave us 7/8. And we do the same thing for subtraction, except for we will subtract the numerators. Now we come to example set C. Now, we would take 3/7, we'll leave that the same. Division becomes multiplication, and we'll take the reciprocal of the second fraction, or just flip it. 3 times 11 is 33, and 7 times 10 is 70. And that's it for problem 1. Now I think I'm going to skip down here to problem 3, because this video is almost running out of time. So let me do number 3 here. Now remember, I told you when you multiply, let's take the prime factorization of all your numerator. So that'll be 2 times 9. 9 prime factorization is 3 and 3. And our denominator, 3 is already prime. And the prime factorization of 10 is 2 and 5. So these 2 simplify out, these 3 simplify out, and you're left with 3/5. Now we go here to problem number 2. We find our common denominator. We have 15 and 5. 15 breaks down to 3 times 5, and 5 is already prime. We bring down our 3, and these two 5's match up, so we bring down our 5 now. 3 times 5 is 15, and 15 is your common denominator. Now we find our numerator. We'll take the new denominator divided by the old denominator. 15 divided by 15 is 1, so we know we take this 1 here and multiply it by that 4. 1 times 4 is 4. And then next we take 15 divided by 5, which gives us 3. And we would take this 3 and multiply it by this 2, and that gives us 6. So 4 over 15 plus 6 over 15 is 10 over 15.